A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. I welcome you all in the online session of electronics circuit devices online course. Hopefully you all are fine and having good health. Up till now, if you have any kind of query in previous sessions and previous topics, please feel free to discuss. I will answer your question and resolve your queries. If you have any kind of question, query, please feel free to discuss. So today's the topic of our today's lecture is op-amp input mods and parameters. And before that, we have started the chapter number 12, that is the operational amplifier, introduction to operational amplifier. In short, it's called op-amp. And in previous session, I have to discuss some kind of little bit of content and topic which we have covered in last session, that is the inverting non-inverting inputs, impedance of op-amp, input impedance, output impedance, and the concept of impedance we already discussed in previous session. Noise aspect we have already discussed, that how much important noise in op-amp and why we remove noise in op-amp. And we already discussed that why we cannot eliminate completely noise from the op-amp. Then we discussed the basic internal arrangement of an op-amp, the differential amplifier input stage, that the difference input of positive and negative available here, and then provide to voltage amplifier gain stage, and then push-pull amplifier output stage, and then we got the output from the amplification from op-amp. Then we have today's topic, op-amp input mods and parameters. In this section, op-amp section, important op-amp input mods and several parameters are defined. Also, several common IC op-amp are compared in terms of these parameters. So, the input signal mod that we have to discuss now. Then the input signal mods, that is recall input signal mod, are determined by the differential amplifier input stage of the op-amp. Then the differential mod. Op-amp have some different kind of mod, that is the common mod, differential mod, because it works on the difference of input as category of input of positive and input of negative, difference of inputs. In the differential mod, either one signal is applied to an input with the other input grounded, or two opposite polarity signal are applied to the input. Opposite polarity of input means the positive input and the negative input that is provided to the op-amp. When an op-amp is operate in the signal-ended differential mode, one input is grounded. We all know if it operate on a single mode, and we all know this thing that the op-amp work on two modes of input, that is the positive and negative operational modes. And if we want to use a single input operational amplifier, then we have to ground a second input that should be positive or that should be negative of the particular op-amp. Up till now, if you have any kind of query or question, please feel free to ask. I will answer your question and resolve your query. In case of where the signal voltage applied to the inverting input in the part A that we have discussed in this figure, that if we want to use a single ended input in the differential mod of an op amp, so we have to ground a particularly one input directly. As you can see in figure 12-4a, that we use a negative inverting signal of an op amp and we get the output from this way. So we have to ground this positive side of an op amp directly. Similarly, if we want to use the positive side of op amp, then we have to ground the inverting op amp directly and got the output from this input. Hopefully this concept have been clear to you. Then in double-ended differential mod, before that we have discussed the single-ended mod of an op-amp in a single-ended inputs, that is this one and the B category of this one. So the in the double-ended differential mod, two opposite polarity that out of phase, two opposite polarity that should be out of phase, and the applied signal in op-amp should be in AC of the category. That AC signal should be provided as an input side of an op amp. Then signals are applied to the input as shown in figure 12-5a. As you can see, these are the two double-ended differential mods. You can see double-ended differential mod, and these are the single-ended differential mod. Now, the amplified difference between the two inputs appear on the output. E- Equivalently, the double-ended differential mod can represent by single source connected between two inputs as shown in figure 12-5d. You can see there are the two category of different inputs in providing in the inverting input and non-inverting input of an op-amp, that V in 1 and V in 2, in the mod of double-ended differential mod. And before that we have discussed the single-ended mod of differential op-amp. So a single-ended mod should be one input be ground and the first category should be provided to get the output. Similarly, same scenario can be fulfilled by the non-inverting input and can get the output here. Now in the double-ended differential mod we have to provide two category of signals, and both the signal, if we use a out of phase category of AC signals, that should be both the signal. You can see, hopefully the screen is clear to you, but I have to zoom more to you. You can see the AC signal is 0 degree, start from the 0 degree and add it 360 degree, and this input of V into is 180 degree out of phase with the another one. That if V in 1 and V in 2 are 180 degree out of phase with each other, you can see. So if we provide both the inputs in this way and this way in the differential mode of supply of the op amp, we have to use the two supply of the differential mode in 180 degree out of phase and get the output in this way. This is the differential mode of the double-ended op amp. Now, this one is also a common aspect of an op amp, that we provide a common source of supply in both the end of inverting and non-inverting input of an op amp, in which we provide the AC signal in this way and this side, and we got the supply output. This mod we also called common mod. This one is double-ended differential mod, or we can say a differential mod, and this one is single-ended differential mod. Hopefully these three mods have been clear to you, and if you have any kind of question query, please feel free to discuss. I will repeat and resolve your query and answer your question. If you have any question, please feel free to ask. This one which I already discuss with you guys that a common mod. In a common mod, two signal voltage of the same phase, that is the same phase of common signal that provided to the side, the frequency and the amplitude are applied to the inputs. That means the frequency, phase, amplitude, all the things. In meanwhile, the signal should be same in both the inverting and the non-inverting inverts and provided to the op-amp and get the output. This is the main thing that discussing in common mod. We applied two input shown in figure 12-6. When equal input signals are applied to both inputs, they tend to cancel, resulting in a zero output. Means that when equal input signal are applied, both the input provide the same signal. Similarly, you can see in this figure that 12-5b applied to both inputs, they tend to cancel. Tend means koshish karna and completely vanish, resulting in a zero output voltage. You can see in this way the output would be zero because the one side of the input is inverting and this one is non-inverting. So signal automatically can provided this way both the signal effect can be cancelled out this level. So this special condition to get the output from common mod of operational amplifier by this technique. This action is called common mode rejection. You can see in this way, common mode rejection. The same scenario which you can see in common mode in figure 12-5b. You can see here, same scenario is happened here. Is any kind of difficulty in this figure and in this figure comparatively? If you can see both the figures, is there any kind of difficulty in your mind to see these things? Is this figure 12-5b and 12-6 both the figure clear to you? And if you have any kind of question query to see these two figures, you may ask with me. I will answer your question. Up till now, if you have any kind of question query, please feel free to discuss. I'm discussing about this figure and this figure. Both the scenario, both the case, both the figures are same in aspects, and to get the output in zero way by this thing. So, discussing this section, we have to read this paragraph. This action is called common mode rejection ratio. It's an important lies in the situation where an unwanted signal appears commonly on both op-amp inputs. If there is a kind of disturbance, if there is a kind of noise distortion can be produced at this level, then the output can be produced at this level. If there is a kind of noise or other kind of thing can be happened, then the change would be happened here. But if the both signal are linear in motion, linear in signal, so there is nothing can be happened here, means that the output would be zero before any kind of disturbance and the kind of noise. So for that purpose, we are using this technique of common mode rejection ratio, common mode op-amp based technique. Now, it's an important lies the situation where an unwanted signal appears commonly on both op-amp inputs. Common mode rejection means that this unwanted signal will not appear on the output and distort the desired signal. Common mode noise signal generally are result of the pickup radiated energy on the output lines from adjacent lines, the 60 Hz power lines or other sources. Means that the kind of noise distortion and interference can be sensed by this common mode category of op-amp. Hopefully up till now all the things are clear to you, and if you have any kind of question query, please you may ask in this online session. Op-amp parameters. Common mode rejection ratio that we have start in this from this paragraph, we are continuing from the side. Desired signal can appear on only one input or with the output as previous discussed. Unwanted signal that appears as noise, distortion, and we can say uh, the noise, distortion, and we can see the interference appear with the same polarity on both input lines are essentially cancelled by the op-amp and do not appear on the output. The measure of an amplifier's stability ability. Unwanted signal noise operating with the same polarity on both input lines are essentially cancelled by the op-amp and do not appear on the output. The measure of the amplifier ability to reject common mode signal is a parameter called CMRR, that is we called common mode rejection ratio, that we already discussed in chapter number 9 and 10. Ideally an op-amp, so the same scenario of common mode rejection ratio in the common mode of an op-amp appear on also in op-amp scenario that we already discussed in the BJT and FET amplifiers, that also covered in this common mode op-amp mod. Op-amp provide a very high gain for differential mod signal and zero gain for common mode signals. Practical op-amp, however, do exhibit a very small common mode gain, usually much less than 1, while providing a high input, high open loop differential voltage gain, usually several thousands time of the voltage gain. So means that it is required the gain of an op amp. The higher the open loop gain with respect to the common mode gain, the better the performance of an op amp. Means that if we want the higher the gain in several of the thousands times, so we prefer the usage of op amp. The higher the input open loop gain with respect to the common mode gain, the better the performance of the op amp in terms of rejection common mode signals. This suggests that the good measure of op amp's performance in rejecting unwanted common mode signal is the ratio of open loop differential voltage. And we already know this thing, that the open loop gain over the common mode gain, the ratio of these two terms, we got the value common mode rejection ratio in an aspect of that. And if we want to mention all these things in decibel, so we have to convert in this way. In the higher the common mode rejection ratio, the better a very high value of common mode rejection means that the open loop gain, the that is AOL, is high, and common mode gain, that is the CMA, is low. Means that we got, if the denominator is less and numerator high, we got the higher value of CMMR. And if the value of common mode gain is higher than the value of open loop gain, then the common mode rejection ratio, the value will be less, will be low. uh, I think this is a basic concept, that denominator is high, then the factor would be low. And if the denominator would be low, this factor of this side would be high. It's a simple thing. All the people know about this thing. Now, now, if we talk about the decibel, the common mode rejection ratio is often expected in decibel. That would be the particular uh, open loop gain over the gain of common mode ratio, dividing to get the log of this value and multiply by the value of 20, we got common mode rejection ratio value. Open loop voltage gain, that is mentioned in this way, all the things are clear to you, and I'm not in this mood to discuss this thing because we already discussed these numerical and also in assignments. So I'm not here to wasting my time in this level. So up till now, if any one of you have any kind of question, please feel free to discuss. I will answer your question and resolve your queries. Up till now, if any one of you have any kind of question, query in your mind regarding today's session and in previous session as well, if you have any kind of question, query, please feel free to ask. I will answer your question and resolve your queries. Uh, Now we are discussing the section 12-3, that is negative feedback of an op amp. The main question in our mind that why the negative feedback is too much important in our amplifiers, why the negative feedback is crucially important in most of the devices, and especially in op amp and amplifiers, and the negative feedback in sense of our linear control systems, digital control systems, and non-linear control system, why the negative feedback is too much important and why we study too much the negative feedback, what is the importance of negative feedback in most of the kinds of control systems. That's the main question that we answer in this 12-3 section, negative feedback. Hopefully after a study of this section, you are able to understand the concept or and answer all the kind of question that I raised. Guys, the negative feedback is one of the most useful concepts in electronics. As I already told you, the application of negative feedback, particularly in op-amp applications, the negative feedback is the process whereby a portion of output voltage of an op-amp is returned to the input. You can see the status of the output can be get by the transfer function of the negative feedback and provided to the negative inverting input of the op-amp. This is the main thing which we observe here, and we all know about this thing. If you have covered the course of linear control system as well as the signal systems and digital signal processing and digital control systems, these are the four main uh, courses in which you can see the negative feedback and the feedback aspect, positive feedback, negative feedback, especially in the course of linear control system. You many times you study the transfer function, feedback control system, the reducing blocks of the transfer function, all the kind of aspect you already discussed, all these aspects. Hopefully, all these things which I am going to share with you guys, things are clear to you in your minds. So application I already told you. The negative feedback is the process whereby the portion by a portion of the output voltage of an op amp when amplifier is returned to the input, as you can see in this way, with a phase angle that opposes or subtracts from the input signal. You can see the signal is start from the 0 degree and this 360 and to at that level, and if we get the output of the feedback form, we get the output from the negative inverting amplifier or inverting input to get the value of that particular signal at 180 degree out of phase. You can see internal inversion makes VF, that is the feedback voltage signal, 180 degree out of phase with the input as compared to the input. This is the main thing that happened in the op amp operational amplifier. Negative feedback is illustrated in this figure. The inverting negative input effectively makes the feedback signal 180 degree out of phase with the input signal. You can see the main thing I already told you guys. Now, can anybody tell me what is happening in this figure? Can anyone of you can tell me that what is happening in this figure? Yes, my friends. Can anybody tell me what is happening in this figure, in the diagram? Hopefully, not a single one can able to tell me that what happened in this figure. So I try my level best to explain this, what happened in this figure. Uh, if anyone of you any kind of query up till now, please feel free to discuss. I will answer your question, resolve your query, or if you want to repeat any kind of aspect, any kind of content, figure, and topic, you can feel free to set ask. I will repeat the concept for you, and if hopefully there is a not kind of things which you want to repeat in these online sessions. So I am discussing the figure that I'm asking from you guys, that the input signal is providing from this side. Same, the user input, the required signal from the user we got from in this way Vin. And to get in the operational amplifier in the non-inverting mode, non-inverting input we got from the positive side of the op-amp, and to provide that output from the amplification which is happening in this op-amp of the figure or layout. At the end, the amplification would be happened. But before that, if the desired signal of the amplification we would not find or we would not get from in this way, so we also get the status of that particular output from the flowing of the negative feedback circuit and provide it to the feedback inverting input in this way. The same signal that is starting from the 180-degree out of phase that is happening before, this is the required signal, and it is in last signal that we want at this time, at this instant. Before that, if we did not get the particular signal, the status that is produced happening in this way produce at this level, and overall that particular status is going through from the negative feedback circuit and coming towards the negative inverting negative aspect inverting input of an op-amp in inserting in this way. So the main aspect of an op-amp that it change it change the signal 180-degree out of phase as compared to the input internally, and cancel out the effect if the desired signal cannot be happened. And if the desired signal can be happened, the signal cannot be cancel out each other, and the amplification would be happened can be happened produce required by the user. That's the main thing that happened from the negative feedback, and that's the main thing that is uh, happening in the op-amp as the form of negative feedback aspect. And we all know that there is a two types of feedback, that is a positive feedback and also a negative feedback that is going from the side. This one is the positive feedback. Negative feedback is the status of the output that is produced at this level. Up till now, if you have any kind of question, please feel to ask. Otherwise, you may read this paragraph that we continue after Adhan. Now, students, we start the session again after the run break. And up till now, if you have any kind of question, query, please feel free to ask. I will answer your answer questions. Please read this paragraph and ask if you have any kind of question. Now, students, we start the session. We continue the session again. Why use negative feedback, and why the negative feedback is too much important in OPAM and the BJT, FET, and linear conventional amplifiers. So, answer of this question is the inherent OPAM open loop voltage gain of typical OPAM is very high, usually greater than um, 100,000. So therefore, an extremely small input voltage drives the op-amp into its saturation output stage. In fact, even the input offset voltage of an op-amp can drive it into saturation. For example, assume Vin equal to 1 millivolt and the open loop gain, that is the 100,000. Then the categorical level we got the value Categorically, we got the value 100 volt by multiplying both the value of input voltage and the open loop gain. And where these values are applicable in this figure, you can see the applied voltage in 1 millivolt. By providing 1 millivolt, we got the 100,000 of voltage open loop gain. We got the value 100 volt by providing the input value of 1 millivolt and got the value of 100 volt at the output side by the too much higher the several thousands of gain of an open loop of an op amp. So this way we have to use the negative feedback, since the output level of an op amp can never reach 100 volt. By providing the input voltage of 1 millivolt, if anyone have you any kind of question, please ask. Yes, if anyone have any kind of question, please ask. Okay, I think no one have asked any kind of question. It is driven deep into saturation that the output is limited to its maximum output levels. As illustrated in figure 12-15, for both the positive and negative input voltage, that would be 1 millivolt. The usefulness of an op-amp operated without negative feedback is generally limited to comparator applications to be studied in chapter 13. With negative feedback, the closed loop voltage gain, that is the ACL, can be reduced and controlled so that the op-amp can function as a linear amplifier. Op-amp can be used as a function of linear amplifier. In addition to providing the controlled and stable voltage gain, the negative feedback also provides to control. That statement is too much important and should be understood by the students, that the negative feedback also provide for control of the input and output impedances and amplifier bandwidth. Table that is represented in the below mentioned figure summarizes the general effects of negative feedback on op-amp performance. So I have to summarize the concept that if you provide that the without negative feedback, a small input voltage drive an op-amp to its output limits and it become non-linear, and that means it would be reached at the saturation level, that it is out of control and cannot be controlled by the op-amp by the setting parameters. So we have to control or adjust the output of an op-amp by the adjustment of its inverting, non-inverting signals, and by the negative feedback of an op-amp to control its output, because the gain of an op-amp was in several times of thousands in the category. Okay. Uh, Now you can see, if you provide the non-inverting input of 1 millivolt at this level of the instant, and the negative feedback, the feedback is not provided by this way, so the output would be too much higher. Means that in 100 volts from its uh, level of this thing at this high level. Now similarly, if you provide the non-inverting input on the negative side of 1 minus 1 millivolt, we got the value of in the magnitude way that minus V max, that would be minus 100 volt. That means it is the out of control way voltage that we got from the op amp at the output side, and this voltage cannot be stabilize the output. We cannot control the output of an op amp by this way, so we have to use the negative feedback to control the output of an op amp. So the main thing to use negative feedback to make the operation of an op amp in linear way and linear smooth way. So we have to use particularly the negative feedback to control, stabilize the output of an op amp. Otherwise, the operation op amp is out of control, cannot be linear, and it would be non-linear. So means that the purpose of an op amp is vanish if we not use a negative feedback in the op amp. So negative feedback is too much crucial and important in the performance of the op amp. So that's the reason we are using the op amp. So these are also some kind of characteristics that we have to study and have to understand that what is happened in this way, that without negative feedback you can see the open loop voltage gain is too high for linear amplifier applications. If without feedback, if with feedback, the closed loop is set to desired value by the feedback circuit. Means that the set points you can see in this figure, the set point that we provide, the set points, the required signal at this side of the output. If you want the output desired output by the user. So we need to control and provide the setting parameters and provide the setting selectivity at this negative feedback to adjust the output of the supply and get the required output. So the basic thing uh, is that to get the user output required output by the user end, we have to provide the setting parameters at this negative feedback effect, that the how much amplitude we need to get at the output side of an op amp. So we need to provide the setting parameters to adjust that particular output amplitude and the phase difference what kind of required and the frequency what kind of we required at this level. So we need to install the negative feedback parameter, the setting parameter in the op amp to get the required output. So hopefully this thing is too much clear to you guys, that why open loop and closed loop is too much important. Closed loop means the with the feedback, and open loop means too much higher the gain, that is out of control. The non-linear amplification would be happened and it is out of control. Now input impedance relatively higher, and that is without feedback, and with the feedback that can be increased or reduced to desired value depending on the type of circuit. Means that the input impedance can be adjusted by the installing of the negative feedback in op amp. Now the relatively low output impedance, if we are not using the negative feedback, the relative output impedance would be relatively low, and if we install the negative feedback with the op amp or in the op amp, the output impedance can be reduced to the desired value, that the required operation by the user, and it is the controllable operation of an op amp. Now, if without negative feedback, the bandwidth of the user relatively narrow means patla, because of the gain is so high, because of gain of too much high, that means the open loop gain of an op amp is too much high. That's the reason the relative uh, open loop gain of an amplifier without negative feedback would be too much high, the bandwidth is out of control, and the relative narrow bandwidth would be happened. Means that the category of the narrow feedback is narrow here, and a significant wider means that the bandwidth would be wide. Most of the quantity of the user and all the kind of devices can be entertained by this with the negative feedback aspect. So up till now, anyone have any kind of question till now, please feel free to discuss, and I'm requesting you guys to share today's attendance in our WhatsApp group. So this session would be end here, and share today's attendance with in our official WhatsApp group. Thank you. And thank you, Zair. Now, what will be the next topic of our next lecture? That is the op amp with negative feedback.